All right, this is example 2. Take a minute, push pause, read through example 2, make sure that you've thought about the things that the steps we're going to be going through for the linear programming problem. 1, you need to identify your variables. 2, we need to look at the profit equation and write that equation. 3, we need to write our constraint equations. And once we write the equations, we'll solve for y, graph them in step 4. Step 5, we'll see our feasible region and we'll grab our vertices off of that region. And then in step 6, we'll plug the vertices in and find how many acoustic guitars and how many electric guitars they should make to maximize the company's profit. All right, so the first thing you've done is you've identified your variables, acoustic and electric guitars. We'll call acoustic guitars X because they came first, and we'll call electric guitars Y. Second thing I'm going to do is I'm going to write the profit equation. The profit equation tells me that when I sell these guitars, how much money this company is going to make. So acoustic guitars yield a profit of $30, so 30 times the number of acoustic guitars that I make plus 50 times the number of electric guitars that I make, that is the profit that the company is going to make through some combination, X and Y, of the number of each type of guitars that they'll produce. Second thing we're going to do is we're going to go through and we're going to look at our constraint equations. This particular problem has nothing about minimum number of guitars that need to be made. So in this one, you need to set up your constraints to be X is greater than or equal to 0 and Y is greater than or equal to 0. I have put X, the vertical line, X is greater than or equal to 0 on my graph, and I would put tick marks shading to the right. Same thing, I've put the horizontal line Y is greater than 0 on my graph, and I've shown tick marks above the graph, which is the beginning of my shaded region. We've restricted this to quadrant number 1. Second thing we're going to do is we're going to write the other 2 constraint equations that this problem needs so we can begin our graph. The other information in here is information about factory A, factory B, how long these factories can operate for each day, at most 10 hours per day. Now both guitars go through factory A and factory B. So when we're setting up the equations for this, knowing that our constraints are based on the number of acoustic and electric guitars that they make, we're going to set up our equations so that we can think about factory A has to operate less than 10 hours a day and factory B has to operate less than 10 hours a day. In factory A and B, they're making both types of guitars, so X and Y variables are going to go in both equations. Looking through the acoustic guitar, it says it requires 2 hours of work in factory A and it requires 4 hours of work per guitar in factory B. The next thing I see is that electric guitars also need to go through each factory A and B, and the electric guitar requires 4 hours of work in factory A and 3 hours of work in factory B. We've used all the information that we've been given, so there are no further constraints that we need to write. So at this point, I need to solve them for Y and graph them. Take a minute, hit pause, and solve equation A, factory A equation, and B for Y, and then we'll put them on our graph. Okay, so we've got our equations and we have our y-intercepts, 5/2. I've changed my scale over here so that 2 boxes is 1 unit. So as I'm going up, I see 2.5 is right over here. Now because I've changed my scale equally in the X and Y direction, meaning I've stretched the graph to be 2 boxes in each direction, I can still count out my slope just using the small individual boxes by going down 1 over 2, down 1 over 2, down 1 over 2. And I've graphed my first line. So just keep that in mind. As long as you change the scale of both X and Y on your graph and they are equal, you can still just count off your slope. Take a minute and put on line B, and then we'll compare and do your shading for line A. All right, so I put the second line on the graph and I did the shading, and I see that I have this area that's shaded in brown with vertices right here. This vertex is going to be 0, 2.5. And I have a vertex right here. These 2 points intersect. And I have 1, 2 is a vertex. And then the last vertex, well, the third vertex down here is about 2.50 as well. And then we do have the vertex of 0, 0 down in the corner. That's obviously going to be the minimum profit when you plug it into your profit equation. So it's up to you now at this point if you're going to plug in your decimals 2.5 or if you're going to round them to the nearest possible guitar that could be made that day. When I look at this problem, this doesn't not possible for a number of guitars, so I'm rounding these down to 2. If you look at the note sheet that I have posted, that's only because they didn't finish that guitar for the day, and we're talking about the number of each type of guitar that should be produced each day to maximize the company's profit. So I'm going to plug in 0, 2, 1, 2, and 2, 0, and discover which combination of guitars to be made would maximize their profit. So take a second, plug those points into your profit equations, and then we'll compare our results here at the end. Alright, so here we are. We've got them all plugged into the table, plugged them into the profit equation, and came up with our maximums and our minimums. I've got 130 as the maximum. To make $130 per day, they need to manufacture 1 acoustic guitar and 2 electric, and they will yield their max profit of $130.